And good morning. Here's a concept map of a Calculus AB free response question. It's from year 2008. It's question number 4, and this is going to be a particle type question. And again, this is a concept map, so it's just a basic walkthrough of how to approach the problem. It is not what you would expect for a finalized answer on the AP exam, but it will get you going in the right direction on how to approach the problem. And let's go ahead and take a look at the question. So here it is, and this is a no calculator question. So it says a particle moves along the x-axis so that its velocity at time t on the interval from 0 to 6 is given by a differentiable function. So that means you can take the derivative of it once. So a differentiable function, call it function v, the velocity function, whose graph is shown above. So when I read this first sentence, the first thing I'm noting is whether it's going to be a rate function or an amount function. So remember, if it's a rate function, it's going to give you the total accumulation if you look at the area under the curve. So velocity is a rate. So this is a rate function that we have. So whenever I do a free response question, I always think about the function they're giving me. Is it a rate function or an amount function? So in this case, it is a rate function. So the area under the curve is going to represent something. So if this is the rate, the velocity, change in time, change in position with respect to time, then all these areas are going to represent the accumulated position. When they're negative areas, then that means the particle or the object is going backwards, it's losing position, and if it is above the axis, then it's going to be gaining position. It's going to be moving in a positive direction. And let's keep reading and see what else they have to say. So it says the velocity is 0 at t equals 0. So let's clean this up a little bit. So the velocity is 0 at t equals 0, t equals 3, and t equals 5. So what they're trying to let you know is that if this is your velocity scale, then right here at time 0 on the vertical scale, you're at 0 for an output. At time 3, you're at 0, and at time 5, you are exactly at 0 for an output on the velocity. So your velocity is 0 at those 3 time values. And they're also telling you that the graph has horizontal tangents at time equals 1 and time equals 4. So right here at t equals 1, you have a horizontal tangent. So that means you're going to be changing direction on your velocity graph. So that's going to be a horizontal tangent, and right here at t equals 4. You have a horizontal tangent. So v prime is going, or v, excuse me, v of t is going to be, or v prime, excuse me, yes, v prime is going to be 0 right at those points. Remember the connection between position, velocity, and acceleration. So if you have a position model, that's going to tell you where the particle is at. If you have a velocity model, that is going to be its rate of change, so how quickly it's moving, in which direction it's moving. And if you have the second derivative of the position function, that's going to be acceleration. So we're dealing with this function here in the graph. And again, what they're telling you with the horizontal tangents is that right at this location, v prime is going to be 0 there. So your acceleration is basically going to be 0, since acceleration is the first derivative of the v function. And also, again, right here, your v prime will be 0, and your acceleration is going to be 0. And then they go on to tell you, it says the areas of the regions bound by the t-axis, and the graph of v on the intervals from 0 to 3, 3 to 5, and 5 to 6 are going to be 8, 3, and 2. Remember, when it's below the axis, it's going to be negative. So on the first interval from 0 to 3, they're saying it's going to be 8 for an area, so this is going to be -8. And the -8 basically means that the particle is losing position. It's going backwards because its velocity on that whole time interval, the velocity on this whole time interval, all these velocity values on the velocity scale, those are all negative outputs. So it has negative velocity, and it's going to be -8, so it's going to be losing position. From 3 to 5, it's going to be 3. So it's going to be gaining position. And then from 5 to 6, so it stops right here at 6, it gets kind of cut off. That's where it's going to stop. So from 5 to 6, it's going to be an area of 2. So this will be -2, which means it's going to lose a total position of 2. It's going to go backwards by a position of 2 on that time interval. And keeping all that in mind, let's see what they have for their first question, part A. So part A, on the time interval from 0 to 6, find both the time and the position of the particle when the particle is furthest to the left. So if it's going to be furthest to the left, then it's going to have gone backwards the most. Another thing that they had in the writing we forgot to mention is at time t equals 0, the particle starts at -2. So it starts at a position of -2, and then it's going to go the furthest left. So if you kind of think about what's happening here, you're going to start at -2, and then you're going to go backwards 8, then you're going to go forwards 3, and then you're going to go backwards 2. So if you thought about this particle, let's go to another page and see if we can kind of map out what's going on here. So again, they say you're traveling along some axis, the x-axis, and they're saying that you're starting at -2 for a position. So there's your initial position, and then the first thing it does, they said it goes backwards 8. So it's going to go back 8, and the reason we know it's going back 8 is because the area under the curve was 8, so it's below the curve, so it's gaining negative position. So it's going to go back 8, which is going to get you to -10. And then they said it's going to go forwards by 3. So they said on the next time interval it's going to gain position, and it's going to go forwards 3. So that's going to put you at -7. And then on the last time interval, it's going to go back 2. Since it was an area below the curve, it's going to lose position. And how much position is it going to lose? -2. So that's what the areas under the curves are representing. So when is it going to be furthest to the left? It's going to have gone backwards the most and basically not recovered. So if it's going to start at -2, it's going to lose all this area. It's going to lose all this position, -8. So after it loses -8, it's going to be at -10. But then it's going to gain some position back, but it's not going to gain as much position as it lost. And then it's going to lose some position again, but again, it's not going to lose as much position as it gained when it gained the 3. So it's going to be furthest to the left at t equals 3. And if it helps, you could even put what we did on our number line kind of into a chart. So if we looked at a chart form of this and did kind of time versus its position on the x-axis. So if we did time and position, so at time 0, at t equals 0, they said we had a starting position of -2. And by the time it got to t equals 3, it will have started at -2, but it lost 8, so it's going to be at a position of -10. And then at time equals 5, because from 3 to 5 they said it's going to gain some positive position, so it's going to go from negative 10 and it's going to work its way back up to a position of negative 7. And then at t equals 6, the end of the time interval, it was at negative 7 at t equals 5, and then it's going to lose some more position. It's going to lose 2 in terms of position. It's going to go backwards 2, so it's going to end up at negative 9. So just to give you kind of the concept. So where is it going to be furthest to the left? Right here at time 3, it's going to be at a position of negative 10. And that should take care of kind of the idea behind part A. Let's go look at part B. Let's clean this up a little bit. We're kind of making a mess here. So part B. For how many values of t on the interval from 0 to 6 is the particle at a position of negative 8? So when exactly is it at a position of negative 8, and explain your reasoning. So we know it starts at negative 2. It's going to lose position and get to negative 10. That's when it was furthest to the left. So to get from negative 2 to negative 10, it's going to have to pass through a position of negative 8. So it's going to do it once when it goes from negative 2 for a position to negative 10 for a position. So by the intermediate value theorem, it's going to have to go through the negative 8 position to get to the negative 10 position. And then it's going to gain position and go from a position of negative 10, and it's going to gain 3. So if it's going to gain 3 from negative 10, it's going to work its way up to negative 7, so it will have to pass through negative 8 again by the intermediate value theorem. So it's going to do it once, it's going to do it twice, and then it's going to go from the negative 7 and it's going to lose a value of 2 on its position. So it's going to go from negative 7 back to negative 9, so it's going to have to pass through negative 8 again. So it's going to have to pass through 3 times. And if you kind of look at it in chart form, what we were doing here, so to get from the position of negative 2 to negative 10, to go from negative 2 to negative 10, you do have to pass through negative 8. So there's once that it passes through. And then to get from negative 10 back to a position of negative 7, it's going to have to pass through negative 8 again by the intermediate value theorem. And then to go from negative 7 to negative 8, it will have to pass, negative 9, excuse me, it will have to pass through negative 8 again. So that's going to be 3 times that it passes through negative 8. And let's go ahead and look at the next question. So part C. On what interval from 2 to 3 is the speed of the particle increasing or decreasing? Give a reason for your answer. So remember, there is a slight difference between speed and velocity. So the first thing I pick up on in this question is that they put the word speed in there, not velocity. So speed is the absolute value of your velocity. So velocity gives you a direction. It has positive velocity and negative velocity. Speed is just how quick you're going, regardless of what direction you're going. So speed, your speed is the absolute value of the velocity function. So speed is always positive. So if we look at the time interval that they gave us from 2 to 3, let's clean up our graph a little bit. So the time interval from 2 to 3, notice we have a velocity here. So this would be some sort of negative value, some sort of negative velocity. And then we go to 3. And what did they say about the velocity at exactly t equals 3? They said the velocity is 0 there. So something is going from a negative velocity. So velocity is negative. And it's going to a velocity that is 0. So if you kind of think about some numbers, let's say maybe this happened to be hypothetically a velocity of -2, and it went to a velocity of 0. So what's happening to the speed? Well, the speed here, since speed is just the absolute value of the velocity, the speed here would just be 2. And then here, the speed would be 0. So it's going from a speed of 2 to a speed of 0. So it says on the interval, is the speed of the particle increasing or decreasing? So we're going to want to say that the speed is decreasing because it's going from a speed of 2. Granted, the speed is in a negative direction, but it's going from a speed of 2 to a speed of 0, so it's going to be decreasing. And part D, they want to know during what time intervals, if any, is the acceleration of the particle negative. So when I read this, I see acceleration. Remember, acceleration is the first derivative of velocity. So if we were going back to what we were talking about before, so we know we have position. We know the first derivative of position is the velocity, and we know the derivative of velocity is acceleration. So they say during what time intervals, if any, is the acceleration of the particle negative. So we know that acceleration is just the derivative of velocity, and they want to know where that is a negative value. So basically you want to know where the slopes on the velocity function are negative slopes. So we want to find the places where we have negative slopes on function v. So this is why they told you where you had horizontal tangent lines, so where it changes direction. So they did say that we have a horizontal tangent line here at t equals 1 and a horizontal tangent line at t equals 4. So where do we have negative slopes on the v function? It looks like we're going to have negative slopes from 0 until we get to 1. So from t equals 0 to t equals 1, you'll have negative slopes. From here, from 1 to 4, you're going to have positive slopes. And then after 4, you're going to have negative slopes again. So from 4 to 6, the end of the time interval, you're going to have negative slopes again. So where you have negative slopes is where your acceleration is going to be negative.